Okay, let's try this again. Okay, and they ask you to translate it or slide it 4 units to the left, 4 left. Okay, so they want the new function, okay? Now, it's impacting it left, okay? Left and right. It says left, so it's either left or right, and in this case it's gonna be left, because they say it's gonna move left, okay? So, we're gonna put it with the x. Remember, everything with the x is left and right. Everything off by itself, like right here, this -2 moves it down 2. This +1 moves it up 1. When it's off by itself, it moves it up or down. It impacts it vertically. When it's with the x, it's always either left or right. So we're going to put it with the x. So we're going to take this x, and we're going to move it 4 to the left. Well, if you move it to the left, you would think you'd subtract 4, okay? But it's always the opposite. So it's really +4.
So it's 4x, right?
Careful, not 4x. Be careful, because 4x means 4 times x, okay? When you multiply, it doesn't stretch it or it doesn't slide it, it stretches it or shrinks it, okay? It didn't say stretch, it never said stretch, it said translate, that means slide, okay? So x plus 4 minus 5. If you would put x minus 4, that would move it 4 units to the right, okay? Now, I'll be honest, I don't know if the computer will take this if you type that in as your final answer. Okay? It may or may not, I don't know. We could clean this up though, okay? We have parentheses here, but they're really not necessary because there's a number sitting here, you just don't see it. It's a 1. And you multiply by 1, nothing happens. So if we distribute that 1, we're gonna get x plus 4, take by 5. The computer may or may not take that answer. I would say no because there's a better solution or simplification of that. We put together plus 4 and minus 5, and that is x minus 1. 4 and -5 is -1. Now, this is where it gets tricky, okay? This answer's right. This answer's right. And I tell you what, this is for people in the back row, okay? Summer's going to answer this for us, though, okay? Because you can see it because you're right up front there, so you need to look at the screen here. So, Summer, should I type in on my final answer g of x? Should I type all of this in right here? G of x equals x minus 1?
No.
What shouldn't I put in there?
The G.
Why?
It's already.
It's already there. If you type this in, is it right? Yeah? Computer's going to say it's wrong, okay? They already have that there. It's like, it says on the screen, g of x equals box. What do you put in the box? X minus 1. That's all you put, okay? All right, and make sure, I don't think I told you guys, I've told some students this, I don't know if I told the whole class this. Be careful when you use the, I don't know what you call it, when you're typing stuff in, and you can like, it'll pull up on your screen and there'll be like, it looks like a little calculator thing. There's a button for x, and there's also a button for multiplication. There's a difference, okay? If you're not sure what I'm talking about, just ask me when you're working on your assignment. If you type in the multiplication button -1, it's gonna say it's wrong, okay? Make sure you use the multiplication button. I'll try to draw this as good as I can, I'm not a very good drawer. Looks like that. The X button looks sort of like,
It's more fancy.
it's like fancy or like kind of slanted.
You can also type X on the keyboard.
Or you can do that, yeah. Make sure it's lowercase x though. If you do capital X, I think it takes that, it'll mark that wrong also if you use capital X. And now do you have to worry about that on a written test? No. Okay, I'm not gonna, oh, you made your X too big. That's wrong. Okay, but the computer's a little picky. Yes, ma'am?
Do the parentheses make a difference? Like, how come it's different?
Well, because what we're doing is we need to have it with the x. So we always, whenever you're putting it with the x, I would group them together. So that, but again, they weren't, in this particular problem, they weren't really necessary because there was nothing sitting out front there. So, and again, would the computer take this as an answer? My response is, I don't know. I honestly don't know. So, and the computer is picky. For example, I'm going to tell you right now, at some point this year, everybody's going to be frustrated with the computer at times. It's not a huge deal, but it's frustrating. If I give you something such as 6x minus 5x, the answer is, now is it 1x or is it x? Who's right, 1x or x?
The same.
They're the same. Does the computer distinguish between them? This is what's really frustrating. Does the computer distinguish between 1x and x? Sometimes it does, sometimes it doesn't. Sometimes it wants 1x, sometimes it wants just x. So if you're wondering, how do I know what to put? Put 1, and if it doesn't take it, put the other. So it's kind of picky from time to time. Okay? What's tricky about this, though, is this. Okay? If you think about this, x minus 1, and it was x minus 5. Okay. Well, to go from minus, this says move it down 5 spots. This says move it down 1 spot. Well, if you're down 1 and then you're down 5, you really went down 4. We're supposed to move it 4 to the left. Well, do we move it 4 to the left or do we move it down 4? Both. Okay? Just so you understand. Again, I want to make sure you guys understand. We keep using the silly putty example. Okay? If you stretch silly putty, if I say make it really, really, really long, stretch it really long, and then somebody came in and saw what I did, they go, oh, they made it really, really skinny. Well, who's right? Did I make it long or did I make it skinny? They both. You can't do one without the other. Okay? So, just so you understand, this is the right answer, but we kind of moved it down or up 4, -5 up to negative. We moved it up 4 spots, but it's just there can be more than one explanation for the answer. Let's look at question number 5. Okay, so again, they give us a function. Number 5, we have absolute value of 4x plus 3, f of x, equals absolute value of 4x plus 3, plus 2, plus 2. What they're doing, what move it, how much 2? 2 down. 2 down. Okay, you move it 2 down. Now, and I'm not making fun here, but just so you know that if you can't answer this, and I get it, it's basically Monday morning. Okay, it's first day of the week.
Wait, why is it 2 down? What do you mean 2 up?
It said 2 down, didn't it?
You said plus. Oh, it wants.
Oh, that's the original one.
Okay.
They want you to move it down 2. Okay? Yeah, we haven't done any work. I just copied it down so far. If you can't answer this, you're a little behind, or maybe you're still on weekend mode here. Okay? We're moving it down. We're moving it. So we're either going to add or subtract. Now, are we going to put it in here with the x, or we're going to put it out here? Out there. Out here is always up and down. In with the x is always back and forth. Okay? So we're going to move it down 2. So what am I going to do with this plus 2? If we're going to move it down 2, we're going to subtract 2. Okay? So we have the absolute value of 4x plus 3. 2 and negative 2 is 0. If you put plus 0, the computer might mark you wrong. I don't know if it will or not. A better answer is just that. Okay? So g of x equals the absolute value of 4x plus 3. So just type in the absolute value of 4x plus 3. Once you get these are really, really simple, but they can be kind of tricky. Okay. Now this one, okay? This one looks a little different. We have f of x, and they even give you a picture, but you need the picture because you can't do the problem without it. It goes 4 minus absolute value of x plus 1. This is not the way we normally write this type of problem, okay? There's nothing wrong with it, okay? But it's just not the way we normally write it, okay? Normally we have the absolute values first. Be careful, I've never told you this, but you should have learned it in a previous math class. Can I just switch, instead of saying 4 minus the absolute value, can I just say the absolute value minus 4? Is that okay? Is that the same thing or not? No, it's not. It's not the same thing. For example, 7 minus 2 is 5. But 2 minus 7 is not 5. It's negative 5. It's the opposite of 5. It's not the same when you switch the order when you subtract. Okay? So,
So could you make it?
what I'm going to do is I'm going to switch these, but what I'm going to put out front is not the absolute value of x plus 1. I'm going to put the negative absolute value of x plus 1. And then the 4 is not negative. The negative goes on the absolute value. So put plus 4. Okay? You don't have to do this, but it looks more similar to the types of problems we've been doing. Okay? This negative, first of all, it's a v. Its absolute value is a v. The negative flips it upside down. The plus 1 moves it 1 to the left, and the plus 4 moves it up 4. They've already given us the graph. We're going from black to blue. The first black is F, second graph is blue. Okay? So in everyday language, what they did, to get from this graph to this graph, it's easy if you just look at the vertex. They went from this spot to this spot, they moved 1, 2, 3 to the right. They simply slid it over 3 right. Okay? So I'm going to put 3 to the right. Now, some students go, what if I go from this one to this one, I want 3 to the left? Well, you're doing it backwards. They want you to go from black to blue. You're starting out with black, then you went to blue. So you moved it 3 to the right. We're moving it. So we're going to add or subtract. Now, is it going to impact the 1 or is it going to impact the 4 if you're moving it right?
The 1.
The 1. It's got to be with the x. and you're moving 3 right. So what are we going to do with 1? We're going to add 3 or minus 3? Minus, because it's always the opposite. You would think right would be add 3. We're going to subtract 3. So we have the negative absolute value of x, 1 and negative 3 is negative 2 plus 4, which makes sense. This minus 2 moves it 2 to the right, and they did move it 2 to the right and up 4. Say it again.
Why is it negative 2 instead of negative 3?
Because we put it with 1.
Oh.
A positive 1 was already there.
Oh.
And then if it was just x, it'd be x minus 3. But it was x plus 1, so we have to minus 3 from that. Okay. Again, and this goes for everybody. If you ever don't understand something, don't just go, okay, whatever. If you don't understand something, ask. That's great that you're asking. Okay? I guarantee you, there's not only one person in each class that has questions. If you're asking a question, somebody else has a question also. Okay, skip number 8. Let's move on to question number 11. 11 is the next one in the assignment. Okay? So they don't give you a graph. You don't need a graph though. Okay? So f of x is negative 5x plus 2. F of x equals negative 5x plus 2. I think that's what it says. And they want you to reflect it over the x-axis, okay? And I will, put this right here, x-axis, reflecting over the x-axis. I think I told you guys that I'm about 99% certain that on your first test, I will give you those notes on reflections. But I mean, you gotta be able to use them, okay? We're reflecting it over the x-axis. So if you took notes, it says you need to change everything if you reflect it over the x-axis. So, negative 5x turns into 5x. Positive 2 turns into negative 2. When you reflect it over the x-axis, everything changes. When you reflect it over the y-axis, only the term with x changes. $13, I think. Okay, with the y-axis, this is a tricky one. Okay. Absolute value of 6x, say minus 2, 6x minus 2. F of x, 6x, and then minus 2. And they ask us to reflect it over the y-axis. Okay? Reflect this thing over the y-axis. I don't want to complicate this, but I also do want you to make sure you understand this. We're going to do it, and I'm going to give you an answer that the computer might take. It might take it. I don't know. I honestly do not know, okay? And what I mean is this, okay? First off, reflecting over the x-axis. So do I change everything? No. Only the term of the x. Now, just be careful here, okay? Just pretend it said over the x-axis. You would change everything, okay? Now, everything, don't write this down, because we're just making something up right here. You would change this entire absolute value of 6x. How would I change the entire absolute value of 6x? Put a negative in front of it, just in front of that, okay? Because, I mean, absolute values are positive. That makes it the opposite. That makes it negative. Then I would also have to change the plus 2, okay? I would change this, and I would change that, if it was over the x-axis. This is over the y-axis, so only change the term that has an x on it, okay? This term right here, 6x, we're going to change it to negative 6x. Now, the computer might take that for a right answer. It might. There is a better answer, though, okay? There's a better answer. And what I'm getting at, put this question on hold here for a second, okay? If I gave you this, say you got your first test, you got, said 90%, okay? 90%. And then I said, oh, wait a minute, I made a mistake on your score. It's not that. Here's your answer. Are you happier or angrier or the same?
That's the value of 90.
It is.
90.
It's 90, okay? And let's say that I'm picking on Garrett, and Garrett gets this score. He sees negative, he just did god awful. He did so bad I took points away from him, okay? He got below a 0. He got a negative 90%. I was really ticked at him. He'd have been better off not even taking it, okay? But what if I gave him this?
Did I get 90%?
So what would you rather have? The absolute value of 90% or the absolute value of negative 90%?
Negative. Well, it doesn't matter.
It doesn't matter, they're the same. So instead of saying the absolute value of negative 6x, what's the same thing as the absolute value of negative 6x?
6x,
Careful, you'll sum out.
absolute value.
Absolute value of 6x. Because what do absolute values do to negatives? Make them positives. What do they do to positives?
Makes them the same.
Keeps them the same. Keeps them positive, okay? So, will the computer take this for right answer? I don't know. Now, I know it'll take this for right answer, okay? And I want to make sure you understand. Let's just do a general absolute value graph, the parent function, okay? If I told you to reflect this over the x-axis, it'd look like this. It'd flip it upside down. What if I told you to reflect this v over the y-axis? If I said take this v and reflect it over the y-axis, what would it look like? You do better than that? How would it change it?
It looked like a B.
How would it change it? Huh?
Not the spots be opposite them? No.
Well, where would this be? Where would this part of the graph be? Close to this one? Close to it?
Be the exact same.
Where would this one be?
The exact same as that.
When you flip a v over the y-axis, it doesn't change it, okay? So should this be negative 6x or positive? It doesn't matter. This is a better answer though because there's less junk. Will the computer take that? I don't know. I really don't know, okay? So, good news and bad news about this section is these problems don't take a lot of time, but they are kind of tricky. So again, my goal is not for you to get this assignment done. My goal is that you understand how to do it. So when you're working through these problems, please ask. If you don't understand something, don't just be like, okay, well, you know, Mike said the answer is this, so I'm going to click on it, okay? Make sure you understand how to get these right answers. Okay, so in this one, I'm going to rewrite this one. It says f of x is negative 3. Negative 3 plus absolute value of x minus 11. That's what it says. Okay, and they want you to reflect it over the y-axis. So the y-axis. Oh, this is even getting trickier. Okay. If you want, and you don't have to do this, you could rewrite it the way we normally do it. We normally put the absolute value of x minus 11 and then the minus 3. You don't have to do that, but if it's easy for you, do that. Okay, we're reflecting it over the y-axis. This is tricky. So we're only going to change any term that has an x. So the only thing I see here is the x. So I'm going to make that negative x. That's all I'm going to change, okay? Now I'm going on over a year's memory here. I remember doing this last year. I think the computer will take that for an answer. If you can answer this, phenomenal, okay? If not, it's not the end of the world. If you did this on a test, I'd give you full credit, okay? But could somebody think back to the discussion we had a couple seconds ago about this previous problem right here, okay? Could somebody think of a simpler way of saying the absolute value of negative x, take away 11, minus 3? Got a guess? You sure? Give it a shot.
I was gonna say x plus 1.
Fantastic, okay? Because think about this. If you change both of the, what do absolute values do to negatives? Make them positives, okay? And this is what you said is a better answer because there's less junk there. You have 2 negatives here, you just got 1 positive, okay? So I think the computer will take this, but that's an even better answer, okay? Now, to throw one more curveball at you, okay? We just said that absolute values make negatives positives. Just be careful on something like this. If I gave you something like this, what would the answer to this be? What would the answer to, if I said simplify the absolute value of 7 minus 3? 4. Good. How'd you do it?
7 minus 3.
Okay, and the absolute value of 4 is 4. Now, I don't want, if everybody thought 4, great. I don't want to give anybody any bad ideas here, okay? But here's what you don't do, okay? Don't say, well, absolute values do what to negatives? Negative positive. 7 plus 3 is 10. Absolute value is 10. The answer is 10. No. Okay. That absolute values make positives, but the first thing you need to do is try to simplify it first. Why didn't we simplify this right here? You can't. You can't simplify it. They're not like terms. Okay. So it's easy, but it's also really, really, really tricky. Okay. Let's try a few more, then we'll stop for today. Let's see, 17. How far does this go? 17? Oh, geez, not too many more. 17, 19. We'll do 2 more, and then we'll stop for today. 17. Okay, so they give us f of x is x plus 2. They ask you to what? Vertically stretched by a factor of 5. Okay, vertically stretched by a factor of 5. Okay? Okay, vertically. Okay? This is where it gets a little tricky also, and I don't know if I actually said this explicitly yet. Okay, vertically, horizontally is with the x. Okay, vertically, first off, you're going to stretch it because 5 is bigger than 1. And what you need to do is you need to times the entire function. Whenever you're dealing with changing the y, you got to change the entire function. We're not going to add 5. We're stretching it. Stretching means you multiply. So you multiply the entire thing by a factor of 5. So if you do that, you're going to have 5x plus 10. 5x plus 10. You multiply the entire thing by it. Now, what if they said, I want you to horizontally, the original one, x plus 2, that looks terrible. Stretch by a factor of 5. Horizontally stretch it by a factor of 5. Will we times everything by 5? No, just what? Just the x. That's a trick question, by the way, there. Anybody see it? What I'm asking you to do is totally impossible. I'm asking you to horizontally stretch by a factor of 5.
Oh, you can't.
You can't what? Yeah, you can't. Nobody here, myself included, can horizontally stretch it by a factor of 5. I can horizontally shrink it by a factor of 5. Why? Because 5 is bigger than 1. You would think it would stretch it. Okay? So that's the wrong word. It should have been shrink. Then you would times just the x. It'd be 5x plus 2. Okay? Anything horizontally is always just with the x. Vertically is the whole thing. Let's try one more. Is that what I said?
Yeah.
One more. 19. Yeah, then we'll start on 27 tomorrow. Okay, so 19. We have what? 2x plus 4. F of x times 2x plus 4. And what are we doing here? Horizontally shrink by a factor of a half. Horizontally shrink. Or, I say, 19. Why does it say shrink? Is that a typo?
I thought you just
Horizontal
said,
stretch.
I thought you just said we can't stretch it.
Huh?
It's half though.
Oh, it's not by 5. It's not by bigger than.
It's less than 1, so I think it's just a typo. Either way, we can still do it though, of a half. So, we're stretching or shrinking, so we're going to be multiplying. Are we going to multiply all of this by a half? No. Only the x. Only the term that's got an x, okay? So we're going to times by a half. So 1 half times 2x plus 4. We got to clean that up though. Half of 2x is 1x, or just x, plus 4. Okay. Question on these. Okay, so you got the last 10 minutes or so, 15 minutes or so. You can click on these if you want to fill in something. You don't necessarily have to, okay? My goal was to spend Wednesday or Thursday and Friday on this section. We may actually start new stuff on Friday, though. I don't know. This assignment's going quicker than I thought. So, okay, where are we at?